welcome back to Maths. Now, so far this week you have been learning about tenths, and hopefully over the past few days you're beginning to get an understanding of what they are and how they work in the number system. Today we are going to be counting in tenths, and I've got this number line here which is going to help us. So what you can see is I've got a number line here going from 0, which I've highlighted, all the way up to 1, and that refers to one whole. And in between 0 and 1, you can see there are lots of little black lines, and they are equal distance apart from each other. And what you actually have got there is this number line divided into 10 equal parts. So each section on that number line is actually worth 1/10. Now, what I've got here is some vocabulary for you. You can see there how we go from 0 up through the tenths there until we get to 10 tenths, which is the same as one whole. And then underneath here, I've got the same maths, but written as a fraction rather than as words. So we go from 0 and then 1/10 all the way up to the end where we've got 10 tenths and one whole. So this will help us with the work we're going to do today. Okay, so this is a kind of clue type question, and this is an example of the questions that are going to be available for you on the website today on our home learning page. So I'm going to read you this clue, and we're going to use the clues to find the answer to this question. So, I count backwards 5 tenths, and my answer is 5 tenths. What fraction did I start with? Now, the first thing just to mention is how the vocabulary is presented in this question. So we have 5 tenths written in words, and we also have 5 tenths written as a fraction. It means exactly the same thing, and you need to understand that in questions like this, you can be given the information presented in different ways. Sometimes in words, sometimes in fractions. So the answer to the question is 5 tenths. We're going to need to find 5 tenths on this number line here. So as before, it goes from 0 all the way up to 1, and the line has been divided into 10 equal sections. So it might be worth jotting down at the end of the number line, where we have one whole, it might be worth writing down that that actually is the same as 10 tenths. It would help if I wrote it properly the first time. So, 10 tenths is the same as one whole. And the answer, we're told in this question, is 5 tenths. So we need to find where 5 tenths would be on this number line. So if we start from 0, we've got 1/10, 2 tenths, 3 tenths, 4 tenths, 5 tenths. Okay? So I would label that middle line there with 5 tenths. I know that's the answer to my question. What fraction did I start with? Okay, this is actually asking us to count backwards, like it says at the top there. If I want to land on 5 tenths, and I want to work at where I started from, I've got to count forwards to see my starting point. So, I'm going to count forward 5 tenths. 1, 2, 3, 4, 5. So I think I'm actually starting the question from here, one whole, or 10 tenths. I'm just going to check my working out by following this question through again. I count backward 5 tenths, my answer is 5 tenths. Where did I start? If I start here, and I count back 1, 2, 3, 4, 5, I am right. My answer there is 5/10. So I started either at 1 whole, you could also put down 10/10. Both answers would get you the mark for that question. This is another type of question you're going to be given today on our website work. It says Amir is using counters to show tenths, and here we have a grid, and this grid has been divided into 10 equal sections. It's not in one long line, it is in a rectangle with 5 sections on each line, but there are 10 parts altogether. So we know that our denominator in this case is 10 because there are 10 equal parts to that grid. Amir thinks that if he takes away 1 counter, he will have 4/10 altogether. Is he correct? Explain how you know. Well, we know that we have 10 pieces altogether, and we can see from the diagram here, he has got 3 blue counters already. So our numerator is going to be 3 to show those 3 blue counters. If he takes 1 away, he will have 4/10, he says. Hopefully you can see that that is not in fact true. He has got 2/10, not 4/10. Now, he is incorrect, but the way that you explain that answer is really important, okay? You need to tell me how you know that he is wrong, and also what he needs to do to get the 4/10 that he wants. So I've written underneath here an example of an answer. Amir is incorrect because if he takes 1 counter away, he will have 2/10 altogether. He needs to add another counter to have 4/10. So if I show you that on here, rather than taking away a counter, for Amir to have 4 counters, he needs to add another one in the grid. And you can show me that as part of your answer as well, if you like. There is one more question type that I'm going to show you, and it's this one here. Ben and Charlie are looking at 2 statements, statement A and statement B. Which statement is true, we are being asked, and we've got to explain why we know. I always approach these questions by looking at one statement at a time. So I'm going to start with statement A, which says 4/10 less than 12/10 is 18/10. So if I try and work out this calculation, starting off with my 12/10 here, and then I've got to look at my vocabulary in the question. Less than. If I want to find something that is less, I need to do a subtraction. So if I am subtracting 4/10 less than 12/10, I'm going to do 12/10 take away 4/10. Now, when we are doing this kind of subtraction, it's quite simple to remember. We do not need to do anything with the denominators. It can stay at 10. What we do need to think about in terms of subtracting is our numerators. So here we've got 12 subtract 4. Now, 12 subtract 4 is 8. So the answer to this statement is not 18/10, it is 8/10. So we know that statement A is false. It is not true. That doesn't mean we automatically assume that statement B is true. Could be a trick question. We've got to do the working out for statement B as well, just to make sure. So, I just get rid of this working out here. We can have a look at statement B. which says 2/10 less than 11/10 is 9/10. Okay, 2/10 less than 11/10. Well, 11/10 is my starting point, and then less than means I'm going to subtract, and I am subtracting 2/10. Okay, again, denominators do not need to change. They can stay at 10, and I am just looking at 11 subtract 2. Now I know that that is 9. 11 subtract 2 is 9. So my answer is going to be 9/10. And that is what the statement is telling us. So statement B is true. And you've now got to explain to me how you know that. Okay? So underneath here, I've talked about the first statement. It says the first statement is false because 4/10 less than 12/10 is 8/10. And that was the working out we did for the first statement. And we've got the numerator calculation there. We know that one is wrong. Moving on to our statement B, the second statement is true because 2/10 less than 11/10 is 9/10. And that was the numerator calculation that we did there. Okay. Hopefully that's been useful, and have a go at the website work today. If you need to look back at this video to help you out, then please do, and I'll be back with more fractions next week.